I'm here to give you guys a quick talk about something I've been working on for the last couple months. So a lot of you guys do hardware stuff. Who does hardware work? All right, well, who's interested in doing hardware but hasn't done it yet? Okay, well, this talk is really primarily for you guys. I'm new to hardware as well. I've been doing this stuff, I don't know, depending on how you measure it, about a year. I've had a couple attempts to get into it before. I've done some microcontroller programming. It didn't go very well. It's really hard. At a certain point, you know, like I can get project to a certain point, but then I usually get discouraged. I don't have like a real EE background. I'm not really a hardware guy. And so it gets challenging beyond a certain basic level. And my core competency is really software. You know, I don't really want to get too much into the hardware stuff. I just want to write code and have it interact with the real world. That's super exciting to me. That's super interesting. So things have finally progressed to the point where a guy like me can actually sit down, write some code, and have things move and not be actually working with like Lego Mindstorms or NXT kits. But while that's interesting, it's not really what I'm about. So I'm a native Oregonian. I'm from here originally. I've grown up here, and that really makes me an indoor kid. I spend most of my time sitting indoors, hiding from the weather, and hanging out on IRC. So hello to all my IRC friends. I end up with a lot of time. You know, when I was a kid, I used to build models, you know, and as I get older, my projects get more and more intricate and detailed, and they take longer to get done, and that's always a challenge, too. And so it's really important to me that I have projects that I can build in different pieces, right? Because the last thing you want to do is work on something for 6 months of evenings, and it doesn't really feel like you're advancing anything. Again, if you get discouraged, then I usually jump out of the project and move on to other stuff. Generally go back to programming, which is where my strength is. So that's always been a challenge. The last, I don't know, year and a half or so, we've had like the Raspberry Pi come out. Arduinos are dirt cheap. You can really start to put together a lot of gear, and that's really fun. So last fall when I was hanging around, I built what I call the Growmon. It's just a little simple instrumentation setup for some plants. It lets you know whether or not you're killing your plants, which is, you know, is surprisingly important. So what you've got on the right is just an instrumented plant. You know, it's doing some wireless stuff. And on the left is a little dashboard. What I've got is, so the wireless sensor, it's just a temperature sensor that's hanging off of there, but it doesn't have to be. It's just, for my example, that's what I use because it was easy to do. I've got some basic thresholding set up, so if temperature goes over my set threshold for a period of time, I get an alert via Twitter, or excuse me, via Twilio. Same thing with humidity. You know, if it goes above or below my threshold, I get a basic notification. Really straightforward stuff. I think it works okay. So right now I've got a temperature sensor hung off of there, but you know, they're just easy to find and they're reasonably affordable. But you can, if you were to pop that off and replace that sensor with something else, well, suddenly you've got a whole ocean of possibilities available. You know, you can set up a decibel meter and find out exactly how often your neighbor's dog is barking. Send them an email when they're bothering you. You can put a motion sensor on there. Folks are doing that with home security. I'm not sure it's the most robust way of getting it done, but it's certainly a way of getting things moving forward. Air quality sensor. There's all kinds of different sensors out there, and that's one of the things that's somewhat limiting in robotics is also the cost of expensive sensors. So for really basic things, you can get some stuff done pretty well. So when I began this project, I'd been following hardware online for a while through different forums and websites, and I knew pretty much what I wanted my stack to look like. I wanted to work with the Arduino because it's affordable and you can get them anywhere. I think they even sell them at Radio Shack now. And I wanted to use the Raspberry Pi because it was really hot. And so when the Pi came out, like, I sat on their website, you know, I sat on like Farnsworth or whoever, and I tried to buy one, but it didn't happen. It took about another 6 months before I landed the gear. And we all want to use Node in as many places as we can because it's a lot of fun. And it actually makes work like this fairly straightforward. And I'll show you a couple of quick examples of that in a moment. So this is what we got. This is the guts of the system. On the left is the instrumentation for the plant. You can see there's a temperature sensor and some other stuff. On the right is the Raspberry Pi, and down the center is a ruler just to give you an idea of the scale if you're not familiar with this gear. So while it's not the smallest thing in the room, it's certainly quite small, and it tucks out of the way really well. And what's nice about electronics is the smaller they get, generally the less power they're going to consume as well. So that guy's actually sitting on a battery on the left there too, but it's at the bottom, and it's held together by high-end elastic banding. So again, here's a Raspberry Pi. These are little tiny Linux-based board computers. I'm running a distribution called Raspbian on there. I think it's about 700 megahertz, half gig of RAM. It's real slow. You know, it's like old school computing. This is the Arduino Uno R3. This is probably one of the most common Arduinos that you're going to see, and if you were to buy a kit off of Amazon or whatever, that's probably what you'd get. But they're kind of big, and I didn't want to use it for this project. So I went out on the internet, and there's just tons and tons of people releasing all kinds of little random pieces of gear. And so I found this through a company called Seed Studio. And what you see here is that's actually an Arduino Nano on the bottom of the board, and on top is a Bluetooth radio. So that's all in one module. All you got to do is just throw some power and data at it, and you're good to go. And it's tiny. It's really, really small. I encourage you to take a look at my plant back there. It's neat stuff. Here's the temperature sensor. So this is just a DHT11. It's like $5. You can see it's got a little plug connector. I didn't have to solder anything to get this project running, and that was cool, you know. The time I spend assembling componentry is time I spend not hacking code, which is really what my interest is. And here it is again. So now you guys know all the components, and I thought, well, I'll throw another slide in, why not? So now that I got my hardware assembled, I had to figure out what I wanted to do for software. And if you guys are going to put together a system of your own, you're going to have to cross this bridge as well. So when I started on this, I didn't know about things like Fermata, and I don't believe Johnny 5 was out there. And so I ended up writing my own kind of ghetto serial protocol. So what you see on the top is the node system sends a request, right? It's saying command get temp. And what's interesting is that in order to string these commands together, I'm basically just looking for a new line character. And once we hit the new line, then we know we have a full command to go on to process. And on the Arduino side, it actually responds with a little JSON object. And so that's actually nice, because we can just take that as is and start doing work. So Node makes things very easy. So this is pretty much the majority of the code that was written. You can see that we're using the Node serial port library, which is really, really nice. We're doing some basic configuration there. We're setting up the port speeds, and we're saying, hey, you know, when you hit a new line character, go ahead and that's a full message, and go ahead and pop that message down to me. And then down at the bottom, you can see the serial.onData. And so when that happens, you get your data, and you're good to go. It's really straightforward. This is some of the Arduino code. And Arduino is like C, C++. All this is doing here, the first part, the top is the main loop. So microcontrollers just sit there churning in a little cycle. And so every time it cycles around, it hits those functions. And so what read BT serial does is it starts reading characters off the serial connection, character by character, trying to string together a command string. When it hits a new line, it sets a ready flag, and then command loop can take that and actually do some work. So this doesn't address actually setting up the Bluetooth connection. This doesn't address any of that work. So this is just getting that data piece. So it's a lot more work just to do very basic things. So what I learned in this process is that debugging on the Arduino is really kind of tough, right? And so if I were to do it again, I probably would use Fermata or something else. These guys have a lot more experience working on microcontrollers. They seem to really like it if they have a project doing so. With the Arduino, the primary way that I'm debugging is just sending, you connect your Arduino to your computer using USB, and now you've got a serial port. And so you just essentially echo data down that serial port and look at it. It's not that complicated, but it's also not that powerful. So you can't do things like set breakpoints and step through code using the standard Arduino IDE. But the Arduino IDE is really nice. It is Java-based. It's quick to get up and running. So that's cool. You can buy this stuff and have it working in 15 minutes. And again, the faster I get to writing code, generally the happier I am. So Fermata is I'm not sure this has been explained very well yet. Fermata is just a simple library that you can upload onto the Arduino, and you can get access to all of the pins and settings on the Arduino through JavaScript. So that's huge. That saves us a ton of time. It gets us back doing what we like to do. It's a really exciting time for hardware. I keep hearing like hardware is the new software, and I think that's pretty much true. Again, I tried to do this kind of stuff a couple of years ago. I didn't get very much progress. It was discouraging. It wasn't fun. Now, I can't say I've spent a great deal of time really boning up on electronics, but it certainly is a lot easier for me to get the things done that I wish to do, and I find that really nice. Little sites like Tindy have all kinds of wonky gear. If you're real brave, you can go buy stuff, and there's all kinds of stuff coming out of China all the time. Tons and tons of knockoffs. So if you're really on the cheap, you can get some good gear going. And I think that ultimately, anytime you do some hardware work, it makes you look hardcore. And that's never a bad thing. So let's go back through some of this stuff. Oh, it's time for a demo. So I wanted to show you guys some of what I've been working with to get things going. I talked a little bit about wanting to split things up. so you can test, you want to be able to get components done one by one. Oh, I'm sorry. Thank you. Is it getting better? Anyone see this? Okay. So we basically have a node server, right? And we have the remote sensor, and it's connected via Bluetooth. And I chose Bluetooth because I know how to get Bluetooth working under Linux. Things like other RF things I wasn't certain of, or they would require some hardware purchase. But I've got Bluetooth built right into my laptop. So that's, again, a shortcut to getting things done. But I didn't always want to have that hardware hanging around when I wrote my web application, right? You want to go to a coffee shop, you don't want to drag a bag of gear with you. And so I wrote a simulator for that remote in. But in order to simulate that, I had to set up, I needed to have a serial port, right? So my web application consumes data and sends data down a serial port. So I'm using a little utility called SOCAT to set up a couple of serial ports for us. So what it does is it sets up two for us, dev PTS3 and dev PTS6. And so these are just little pointers back at each other. So if you send data down 3, it pops out a 6. If you send data down 6, it pops out a 3. It's really that simple. And so now that we've got that, we can run a little simulator. So I wrote a simulator for the remote end. Oop, and we've lost it. What? Where did you go? No. There we go. Okay. And so all the simulator does is it plays the role of the remote port. Okay. So we're going to set him up on 3. So what he does is he binds to the serial port, and he just starts making some phony data. But what he's really waiting for is somebody to ask him for some data. Remember, it's a request-response system. So it's going to wait for a request from the node stack. So let's go ahead and grab that guy and get him over here. And if it works, we'll see some ping-pongs back and forth. And that could be really fun. If it doesn't work, it's not going to be fun. Okay? And so we'll set this guy up on port 6. This is the node stack. So this is nothing fancy. You know, it's a really basic Express site. I'm using Socket.io to send this data up to a web client. Okay, so now we're seeing some data flow back and forth. Right, so you see the request, you see the response. We'll watch that. Yay, look at it go. And then I'm presenting all of this on a little simple Bootstrap-powered website. Because Bootstrap's where you go when you don't actually want to do front-end work. And that's all there is to it. And so what I like to do is just set this up at home on a tablet, and you set it next to the plant. And so once I'm done talking, I'll get that guy running for you if you're interested in poking at it. So that's it. I mean, that's as simple as these systems get. All right, thank you. I did have some other things I wanted to say, but I do appreciate the applause. So really the only other tools, so I had an opportunity to play with some tools I hadn't had an opportunity to really mess with outside of this project. And so we talked about SOCAT. I just want to mention these things because they're really pretty neat. I'm using HCI tool to look for Bluetooth devices that are available for pairing. From that, you can get a hardware ID. I'm not going to run it because it takes a while to complete. And with so many people in the room, I don't know how long it would take. So once you have that hardware ID, you can pass it into another utility called RFCOM. And RFCOM takes a hardware ID as an argument, and then it'll set up another local serial port that you can work with. So now you've got a serial port. And once you send data down that, if your device requires you to pair, you need to provide a PIN number somehow. And so I'm using Bluetooth Agent for that. And then we already saw SOCAT. So that's pretty much it. I mean, it's box stock, Raspbian all the way through, and all this stuff is available up on GitHub. I've got the code functioning. I've got the documentation. It's pretty basic, but you guys should be able to hang your way through it. And I've got a build list of material if you guys want to buy some of the gear. I don't think this would be hard to get running on any other gear that you can find out there, though. The code's dead simple once you start reading through it. Okay, and that's it. That's my presentation. All right. Thanks, everybody.